in modern AI infrastructure. It's a huge privilege having you here.
Thank you.
OpenAI has always pushed the limits of infrastructure. Can you tell the team a little bit here today as to how your team actually develops GPU software and how have technologies like Triton evolved?
Yeah, for sure. Well, first of all, thanks so much for having me. I was here 2 years ago. It's my great pleasure to be back now. Look, our way of looking at things is there's no one way to fit all applications, and we really try to meet users where they are. So for that reason, we've developed multiple solutions. So for workflows where speed of iterations is more important, we've developed Triton, as you mentioned. So this is typically what researchers will use. But more and more, we've been in a case where we've had to hyper-optimize performance, and Triton didn't give us the level of control that we wanted. So we've developed Gluon for that, which is a lower-level language. And this way, we've been really able to optimize our kernels for AMD, among other things. Yeah, like our agents have become extremely good at both of them, and we've worked with AMD on both of them as well. Yeah, and more and more what we're seeing is agents slowly taking over. They're getting just very good, as you just mentioned, at writing this kind of code.
Amazing. So look, I think the work you have done with Triton and now Gluon, right? It's been really, really moving the ball forward for the entire industry. Now, we began our work together with 300 and extended at 350, but now we're collaborating at a different scale with 450 and Helios. So would love to hear your thoughts on how that collaboration has been going and how has that experience been?
Yeah, super well. It feels like ages. I think we started years ago on hardware co-design, when MI450 was in the very early prototyping stages. I think we're able to work really well together, and it's so nice to see the outcome of that and the chip. And more recently, we've been working very, very deeply on software enablement for MI450, both for our models, but also for the broader ecosystem. So a lot of this development has been done open source. And yeah, we're collaborating on the full stack now, down to the very low level LLVM code generation. So that all the nice hardware advances that came with MI450 can be properly leveraged, in end-to-end applications.
Yeah, and you got your Helios racks, so tell us a little bit about that.
Yeah, it worked. We got the chip and very quickly, like a single engineer in a few days was able to confirm that everything worked. Obviously, we have to optimize performance more, but we're very confident we can get in a very, very good place.
Awesome. That's awesome to hear. So look, one of the more amazing things that we've done recently, right, is our teams have collaborated even more closely in terms of using AI to program AMD GPUs. So would love to hear your thoughts and anything you can share with the audience.
Yeah, no. I mean, everyone in this room knows how much agents are taking over our jobs, in a sense, as kernel engineers. And it's been amazing just to see how much better they've got over just the past 6 months. And just now they're extremely good at generating just high-quality GPU kernels in a way that we're not before. And it's been very great collaborating with AMD on just making sure that agents not only are capable enough, but also have all the right context they need to be able to make good decisions and good optimizations.
That's great to hear. Yeah, I think the quality of code that's getting produced by AI-assisted kernel generation has been truly remarkable through our collaboration. Yeah. Very excited. Now, as you look ahead, right, what crystal ball do you have for us for the future of AI software ecosystem and collaborations like ours?
Yeah, so there's two things that really come to mind. One, as we keep talking, is just how good agents are getting. And the other one is, I think, how much the open approach to software of AMD is enabling, not only for OpenAI, but I think for the industry as a whole. I talked a little bit earlier how we've been collaborating on LLVM code generation. LLVM is an open source project. The entire compiler stack from AMD is open source. And that has allowed us to make our agents really good at very, very low level code generation, down to scheduling instructions in assembly. And this has led to very, very significant performance gain that I don't think would have been able to achieve in a fully closed source stack.
Yeah, that's one of the real sort of big value propositions that we have to offer, right? Because everything that we do is in the open, and the fact that AI can actually pick that up is a big one.
Yeah.
Thank you, Philippe. We truly appreciate the partnership, and we're really excited about what we're going to build together.
Yeah, my pleasure. Thank you so much for having me.
What you just heard is extremely important. When we combine better abstractions with AI-assisted development and close hardware-software co-design, we can create some incredibly powerful capabilities. And that's exactly aligned with our strategy. Now, everything I've shown you so far has been about AI, but ROCm is also a great stack for developing high-performance and scientific computing applications. From frontier models to climate simulation, we use the same ROCm. The same library, same tools, same AI-assisted development, one open stack for every single workload. And in fact, when you look at our roadmap, we have retained that very strong focus on HPC and scientific computing. Just like MI455 leads in AI compute with FP4 and memory performance, MI430X leads HPC compute with FP64 and memory performance. Two platforms purpose-built for two very different classes of workload. The MI430X is built by leveraging our modular chiplet architecture to deliver a purpose-built variant with native FP64 hardware, giving customers leadership performance across AI and HPC in a single platform. And this is hardware double precision, not emulation. For the scientific community, that distinction is everything. This product delivers 288 teraflops of FP64 compute, nearly 9 times better than competition, and the same leadership, memory capacity, and bandwidth of MI455. The MI430X ships in the first half of 2027. This is why leaders in sovereign AI love this product. The first sovereign exascale AI factories in both US and Europe are being built on the MI430X. Discovery at Oak Ridge National Labs, and Alice Ricoh with CNES and GenC in Europe. So look, as we look ahead, let me leave you with this thought. Every so often, our industry goes through inflection points. We've all felt it when neural networks first started recognizing cats and dogs, when transformers changed what was possible with AI. I believe we are experiencing another one right now, a real inflection in the ability of AI to program complex hardware systems. Building on the surface area that's been exposed from open source software and leveraging the power of abstracted interfaces, AI is making it dramatically easier to program AI systems. We cannot wait what you will build with it. Thank you. Now, AI is getting pervasively infused into all forms of computing. Enterprises are experiencing the same shift with their own unique requirements. So to tell us more about that transformation, please welcome to stage Senior Vice President and General Manager of Compute and Enterprise AI, Dan McNamara.
Thank you, Vamsi, and good morning, everyone. It is a great pleasure for me to bring to you the third pillar of our strategy, which is powering AI everywhere. And the vision behind this has remained the same for several years for us, to deliver the right compute engine to the right workload, and then continuously drive optimization points across our entire portfolio, from CPUs, GPUs, networking, and FPGAs. So, building on what we've already shared, I'll cover how our strategy comes together across our enterprise portfolio and how the foundation we built with the CPU franchise has truly positioned us for the next era of AI across multiple deployment models. So Lisa talked about the frontier model and hyperscale landscape and just the rapid and massive advances we've seen over the last 6 to 12 months. And those advances are driving the adoption of AI well beyond the cloud. And as AI continues to grow, it will demand compute beyond the massive purpose-built data centers that we all know and love, extending into enterprise, personal, and physical AI. And each of these brings a new or unique set of requirements. Enterprises are usually constrained by power and cooling. Personal AI usually must operate within a fairly limited compute and memory footprint, and physical AI must perform reliably in real-world demanding environments. And AMD is the only company delivering a complete portfolio that spans all of these development models. So I just mentioned that our journey began in the data center with our CPU franchise, and I want to touch on it a bit. With each generation of EPYC, our strategy has been to listen to our customers, address their evolving needs, and deliver the highest performance, lowest total cost of ownership, and the fastest time to value. As Lisa mentioned earlier, we've introduced many industry firsts across our generations that our enterprise customers has actually asked for. And that customer focus has brought us to where we are today, with EPYC as the leader in enterprise computing. And over the last 3 years, there's been very, very strong adoption across the enterprise, with the world's largest companies moving more and more workloads to AMD. And it's reflected in a number of places. First, public cloud, where our VM consumption has grown at 76% CAGR over the last 3 years. And our on-prem deployments with our OEM and ODM partners is growing quite aggressively across key industries. But just as important, this position allows us to understand truly the diversity of the workloads that our enterprise customers run every day. And each workload places new demands on the CPU. Some require a maximum thread count, some depend on per core performance, while others depend on memory bandwidth, cache efficiency, or I/O performance. The really important point is that there is no single SKU that solves every enterprise application. And that's why our EPYC portfolio with Venice spans 8 to 256 cores with a range of power, frequencies, and I/O capabilities, giving customers the flexibility to choose the right solution for their workload, and most importantly, at the most optimized cost. So Lisa mentioned this earlier, and now we all know, we covered Venice, and she showed how we have strong leadership across AI host nodes and the agentic workflows. But I wanted to show you how Venice actually leads across the general purpose workloads of the enterprise, and these workloads that are running, our customers rely on every day. As you can see, we have a minimum of 2.5x the performance across our competition, across these very, very important enterprise workloads. So now, as we all know, agentic AI is really the next major transition for the enterprise. And it truly is a force multiplier for enterprises. And adoption is accelerating. In fact, the latest data here shows that nearly every enterprise next year will have some form of agentic deployments. And as enterprises move from pilots to production deployments, we've talked to CIOs all the time, and they are looking at 3 major things. First, predictable infrastructure cost and token costs. Secondly, making sure the data is secure. And then lastly, and sometimes this is overlooked, right? Integrating AI into their existing infrastructure. It's not all greenfield out there for the enterprise customer. So to solve these problems, we truly believe that it's going to be a distributed deployment model that leverages frontier models, cloud services, on-prem infrastructure, and of course, AI clients. And as AI has moved from chatbots responding to prompts to agents doing real work, writing code, summarizing documents, and running complex flows, the requirements have evolved also. And those are exactly the requirements we've been designing for multiple years. So while AI will be deployed across all these environments, the on-prem deployments in our enterprise customers have fairly unique constraints. First and foremost, power, cooling, really big challenge, and space. And of